Frontiers was founded with a very simple mission. We're here to make all of science open so that everyone can live a healthy life on a healthy planet. And here in this Frontiers Forum, we do like to highlight exceptional scientists who really make an impact in this mission and to really try to increase human and planetary well-being. So today's forum speaker, Axel, he will actually take us into the very, very heart of what it actually means to be human. Axel Cleeremans is the professor of cognitive science at the Free University of Brussels. He's also the research director at the National Fund for Scientific Research in Belgium. And many of you may actually know Axel as the editor-in-chief of Frontiers in Psychology. He was actually one of our very first and is today one of our most successful chief editors. He's built an absolutely amazing and the most vibrant editorial board of more than 11,000 researchers from all over the world. And together they have made Frontiers in Psychology by far the #1 most cited multidisciplinary psychology journal in the world. So in his real research life, Axel is also one of the most eminent experts on how our brains become self-aware, aware of our thoughts and feelings, aware of ourselves in the wider world, and aware of what we know and what we may not know. This awareness is consciousness and perhaps the defining feature of what makes us human, but it certainly is the prerequisite to our personal and collective well-being. It is my absolutely great pleasure to hand the floor now to our friend, Axel Cleeremans.
So I'd like to begin by sharing this amazing drone shot of me standing in Black Rock Desert, the place where Burning Man Festival is organized every year. And I was there to shoot a wonderful science documentary titled The Most Unknown, which you can see on Netflix. And in this documentary, 9 scientists working in completely different fields got to meet each other without knowing each other. And I was there to meet Luke McKay, who's an astrobiologist working on the organisms that live in the hot springs in this desert. The movie is truly great. It's a terrific celebration of science, and I highly recommend that you watch it. Now, as I was standing there, I was experiencing many new sensations, the incredible landscape, the scorching temperature, and as you can see, I had kept my blazer on, the dryness of the air and the very unusual texture of the playa sand, which is both hard and soft. I was also experiencing lots of emotions. I was absolutely thrilled and overwhelmed, really, by being there. And I was also thinking about all of this. Now, all these sensations, emotions, and thoughts combined to define my presence to the world at that particular moment in time, what it was like for me to be there, in other words, my consciousness. Now, we know that all those mental states, the sensations, the emotions, the thoughts, well, all of it emerges out of the biological activity of the brain as it interacts with itself, with the world, and with other people. The human brain is probably the most complex thing we know of. We know that it has about 86 billion neurons and around 85 billion glial cells, the function of which remains a little bit unknown so far. And we also know that each neuron has about 10,000 connections to other neurons. And understanding how this massive network produces conscious experience is one of the great scientific challenges of the 21st century. And indeed, the study of consciousness is now widely recognized as one of the big unknowns, along with the origins of life or the origins of the universe. So what is consciousness? Well, to answer that question, we can turn to philosophers, and here you have John Searle. Philosophers have been thinking about consciousness for a much longer time than scientists, and he writes, well, consciousness consists of those states of sensation or feeling or awareness which begin in the morning when we awake from a dreamless sleep and continue throughout the day until we fall into a coma or die or fall asleep again or otherwise become unconscious. Now you're probably thinking, well, this is not much of a definition, but it captures the central fact that consciousness is just what it's like for you to be a feeling person who is aware of herself and of the world around her. But the truth is, nobody knows. Nobody knows what it feels like to be a bat chasing insects at dusk through echolocation, a sensory system from which sonar was later inspired. What it's like to be a bat was the cunning title of an article published in 1974 by the American philosopher Thomas Nagel, who pointed out that no matter how much we could know about the nervous system of bats, we will never know what it feels like to be the bat chasing insects at dusk. In other words, consciousness is a private phenomenon which is in principle inaccessible to outside observers. I don't know what's going on through your mind right now. Maybe you're bored already or excited for the rest of the presentations. Only you do. And that is a challenge for the scientific study of consciousness, for it uniquely requires combining first-person subjective data and third-person objective data. And this quandary is also what led the philosopher David Chalmers to describe consciousness as the hard problem for the cognitive neurosciences. Now, Chalmers writes, and this is 1996, 25 years ago already, that numerous books and articles dedicated to consciousness have appeared recently, and one might think that there is progress, but in reality, says Chalmers, all these works have ignored the hard problem. Often they concern what one might call the easy problems of consciousness. How does the brain process information? How does it integrate information? How do we produce verbal reports on our mental states? These questions are interesting, says Chalmers, but answering them does not solve the hard problem. Why is it the case that information processing is accompanied by subjective experience? Chalmers' point here is to say, not only do we fail to understand how the brain produces consciousness, but also why we have subjective experience at all. And the trouble is that we can imagine all sorts of systems, and we'll talk about this later, including computers, that are capable of doing much of what we can do, yet that fail to experience anything at all. And that raises a question about the extent to which phenomenal experience, what it feels like, is connected with what consciousness enables us to do, the functions of consciousness. And I should add that this question is one that remains very much debated today. So what are those easy problems that Chalmers talks about and dismisses? They're really hard problems. Here, for instance, you have the Venus flytrap, Dionaea muscipula, a carnivorous plant that is able to capture insects through mechanisms that biologists don't fully understand yet. The plant is clearly sensitive, it's capable of action, yet few would be willing to grant it any kind of awareness. There's probably nothing it's like for the plant to be the plant. And of course, no one would be willing to ascribe moral responsibility to the plant for the murder of the insect. It couldn't have done otherwise. So consciousness is not sensitivity. Here is another example taken from the amazing robotics work of Boston Dynamics. We should all appreciate how complex a robot such as Atlas is. This was simply unthinkable just a decade ago. And here we sort of recognize a form of agency. We have the impression that a robot has goals, a purpose. One can sort of feel intentions, but again, nobody would be willing to ascribe awareness to the robot. It's just a machine unable to feel anything. So consciousness is not agency either. And finally, here's the amazing work of DeepMind and their incredible deep learning system called AlphaGo, which managed to beat the South Korean Go champion Lee Sedol in 2016 at this wonderfully complex game of Go. I think I must have spent about 6 months of my life trying to play Go, or if you put it all together, and I never raced beyond the level of a sort of moderately skilled amateur. And yet AlphaGo decisively bet the world champion, so exhibiting superhuman intelligence. AlphaGo was later itself bet by its descendant, AlphaGo Zero, which learned all of Go in 4 days with zero human input, just playing against itself. Nobody who knows Go would have thought that was even possible. It truly is a stupendous achievement of modern machine learning research. And yet, when AlphaGo wins the tournament, it is Demis Hassabis and the DeepMind engineers who drink the champagne. In fact, AlphaGo is not even aware of its feat and derives no pleasure at all from winning. Consciousness is not intelligence. Finally, and this is very important, consciousness is not a single thing. Instead, it's a multifaceted process that involves at least 3 important distinctions. First, there's a distinction between level and contents of consciousness. Level of consciousness simply refers to the state of wakefulness, to the fact that you're awake versus asleep or in a coma. Contents of consciousness, by contrast, refer to the fact that subjective experience is always about something. You're aware of being in a great talk, you're aware of the taste of an apple, and so on. And level and contents can dissociate. For instance, when you're asleep and have a dream, you're obviously unconscious, but you're also experiencing the contents of your dreams. And then some patients exhibit the opposite dissociation. They are awake, they open their eyes, they have circadian rhythms, but there's nobody home. Those are patients in the permanent vegetative state. There's no way for you to interact with those patients. And that is where the study of consciousness has immense clinical implications. For the diagnosis and treatment of patients who exhibit disorders of consciousness has obvious great societal import. Second, there's a distinction between awareness of the world, perceptual awareness, awareness of yourself, and self-awareness, and awareness of the mental states of other people, what we call theory of mind. And there are complex relationships between all three and considerable debate about those relationships. For instance, do people who suffer from autism, who have difficulty understanding the mental states of other people, also exhibit disorders of self-awareness? Is self-awareness a prerequisite for perceptual awareness? Those are all big questions that are currently being debated. And finally, there's a distinction between the functional and the phenomenal aspects of consciousness. The functions of consciousness simply refers to what consciousness enables us to do, while its phenomenal aspects refer to what it's like. And there's continuing debate as well about the relationships between the two. This is Chalmers's heart problem. Can you imagine a zombie that is a being that is exactly like you, who can do everything that you can do, talk about its mental states and so on and so forth, but for whom it doesn't feel like anything to be that zombie? Some will say, yes, that's possible. Many of us will say no. So consciousness is not a single thing. Let me move on to theories of consciousness. There's about as many theories of consciousness as there are actors in the field. You can't be someone in this domain without having your own theory of consciousness. And there's a wide range of positions about it. I won't go through all of them here, but they range from dualism and Mysterianism, the idea that we'll never be able to understand anything about consciousness, to panpsychism, the idea that everything is conscious. And I'll focus on the fortunately much more widespread view that consciousness is simply an emergent property of certain biological systems. That's what I'll focus on. And if you look at the subset of those theories, there's really two big ideas. And the first one we owe to the American philosopher Daniel Dennett. And he says roughly, well, consciousness is just fame in the brain. The brain consists of many competing systems, and what you're conscious of at some point in time is just driven by whatever system has won this neural competition. And there's nothing else to explain. The second idea we also owe to an American philosopher, David Rosenthal, and it's completely different. For Rosenthal, whether a pattern of neural activity somewhere in your brain becomes conscious depends on what he calls high-order thoughts. So if I see an apple in front of me here, there's some apple-related activity in my visual cortex at the back of my brain, but that remains unconscious until it's noticed, so to speak, by high-order systems, perhaps located in my frontal cortex. You're not aware of those high-order representations as such, but their existence make the contents of the target first-order representations conscious. So two completely different ideas, fame in the brain and high-order thoughts. So here's how the fame in the brain idea plays out in a theory that has been put forward by Bernie Bars and Stan DeHaan. The idea here is that the brain consists of many modules that can carry out their work automatically and unconsciously. For instance, we have modules to recognize words or faces and to make decisions and so on. But then there's a set of high-level modules that are connected to each other through long-distance cortical-cortical connections emanating from layer 5 of cortex and extending from frontal cortex to parietal cortex and to temporal cortex. And that forms a sort of global hub, the neural workspace. And when an unconscious module connects with that workspace, then its contents become globally available for the rest of the brain, and so they become conscious. You can now talk about them, act on them, use them in reasoning, and experience them. that is fame in the brain. Rosenthal's idea is a little bit more challenging to convey graphically, but here goes. A mental state is conscious if we are conscious of being in that mental state. And we are conscious of being in a mental state when we have a thought that we are in that mental state. In some, says Rosenthal, a mental state is a conscious mental state in virtue of having a higher order thought that you yourself are is in that mental state. Now, the key here, again, is that you're not aware of having the higher order thought. Those remain unconscious, but their existence makes you, as a subject, aware of the first order contents. So you can think of this theory as involving a sort of inner awareness. It's not enough to perceive things in the world. You also need to be aware of the fact that you yourself is now perceiving something out there for that something to become conscious. With all of this in mind, then, how do we build a science of consciousness? Well, we begin with the idea that every mental event is necessarily a neural event. So that basically excludes dualism. Everything that goes on in your mind comes out of the biological activity of your brain. Then, to find what people have called the neural correlates of consciousness, we can use the contrastive method, that is, design experiments that make a clear contrast between conscious and unconscious processing or between different conscious contexts. Then, of course, we use brain imaging methods to see the brain in action. And finally, and this is key, we need to combine those subjective and objective data, what people say they experience and what is going on in their brains, so as to hopefully land on those neural networks that are uniquely associated to conscious processing. And that really is the tricky bit for, as I mentioned earlier, consciousness science is rather unique in this respect, in requiring the use of subjective, private, first-person data. So here's a great example of this contrastive approach. What you see on the screen right now is a word sandwiched between two visual masks and flashed so quickly that it's impossible to read it. Now, it turns out you may see it, but this is not research-grade material. For participants in the relevant experiments, the word is invisible. So the question is the word still processed somehow despite your remaining unconscious of it? And the answer is yes. Compared to a condition where there's no word at all, what you can see is that the presence of the word engages this area of the brain, which is depicted in red on the picture. And this is the left fusiform gyrus, a region of the brain which we know to be involved in the processing the visual shape of words. That is what's called subliminal perception. People don't see the word, but it leaves a trace in the brain. And we can compare that with this situation in which the word should be visible. So it looks very much like the other display, except we play around with the temporal delays between the different elements of the display so that the word is now visible. And here's what happens if you do brain imaging on that condition. Not only do you light up the same fusiform gyrus more than in the invisible case, but you also engage, and this is really key, an entire network of areas, which the hand would call the global workspace. That is the difference between subliminal and supraliminal perception. In one case, you're unconscious. In the other case, you're conscious. And when you're conscious, you engage a wide and a widely distributed set of brain areas. We can extend this contrastive method to a lot of other cases. I'm not going to go through all of them, rest assured, but we can look at knowledge about the present, perception, knowledge about the past, memory, and knowledge about the future, action. And for all these cases, we can design experiments in which this contrast between conscious and unconscious processing is built in. In the first row, you have paradigms where subjective experience changes, whereas stimulation and behavior remain constant. An hallucination is perhaps the best example of this. If I see Fred as a pink elephant, that's clearly something that's in my mind as opposed to being out there. In the second row, you have paradigms where subjective experience remains constant, but stimulation changes. And in the third, we have cases where subjective experience remains constant, but behavior changes. So here's a couple of examples of such situations. Here's a beautiful and very powerful, if it works, movement illusion. You should see these circles moving, particularly in the periphery of your visual field. Now, there's no movement in the stimulus. In fact, you can print this on a piece of paper and it works even better than on a computer screen. So clearly, your perception of movement is a sort of hallucination. Nothing moves in the stimulus, and we could imagine experiments aimed at contrasting what happens when you have this illusory movement on the one hand, and when you're perceiving actual movement in the other hand. So this is clearly a case where something changes out there, which is not reflected in your subjective experience. Here's an opposite example, a situation where something is changing, something is changing out there, yet you fail to perceive it. Um, so this is not a picture, it's a movie. It's a slow movie that loops back and forth. And there's a change going on right now. So we're not going to play this game for lack of time. Um, but as you keep watching this, think, well, is there something changing in this movie? Um, and if it is, if there is something changing, what is it? What turns out to be changing is the entire facial expression of the central actor, who goes from an expression where he smiles to an expression where he's emotionally neutral. If you focus on the mouth of this character, you'll be able to sort of sense the change that takes about 12 seconds to unfold. This is a phenomenon called change blindness. Here's a change that occurs in the middle of your visual field. You're completely paying attention to it. You have the instruction to look for a change, and yet in experiments, it could take up to 40 alternations between the neutral and the smiling expression for people to be able to detect it. Here's another example of failing to see everything. There's actually 12 dots in this picture, yet we seem unable to perceive more than 3 or 4 at the same time. There's a complicated story involving attention about why this is so. But again, it's a clear example of cases where we think we should see everything, but we fail to do so. We only perceive, in fact, a small portion of what we feel we're perceiving. And here is perhaps the best illusion of all. Would you believe it if I tell you that A and B are exactly the same shade of gray? Um, it's really hard to be convinced that this is indeed the case, but there's a simple trick we can use to make it clear by removing the entire context, and then you can see that A and B are exactly the same shade of gray. So what's going on here? Well, what's going on is that your visual system automatically laddens up B in virtue of the fact that it knows that it's in the shade of a cylinder. That explains color constancy. It explains why a piece of white paper always appears white, whether you're looking at it in the noon sun or in the shade of your living. And then the second factor is that we also have high-level knowledge about how playing boards such as this are structured. So we project a lot of our expectations on this scene to make it appear as though A and B are differently shaded, whereas in fact they're exactly identical. We see things that are not there. We fail to see things that are there. We fail to see everything we think we should see, and we see differences where there are none. This all tells us that our subjective experience involves not just perceiving what is out there, but also projecting our own expectations and biases onto the world. So in a sense, we're building reality as much as perceiving it. And this has led Anil Seth to say, well, we're all hallucinating all the time. And when we agree about our hallucinations, that is what we call reality. I think it's a great quote. So, but the point is, perception is an active constructive process rather than a passive state of receiving information. And this active construction is also biased in many different ways that can inform us about the structure of our subjective experience. Now, these are just a few examples out of hundreds of studies that are currently going on trying to figure out the neural correlates of consciousness. And the team of Liad Mudrik, in particular Itai Yaron, recently carried out a study that was very interesting. which consisted of taking hundreds of empirical studies about consciousness out of the literature, looking at them and figuring out, well, which theory do they support? And do they always support a theory, or do they challenge those theories? So what you can see on the left is that global neural workspace is by far the theory that is receiving the most attention from people who do experiments. There's a few others, recurrent processing theory, integrated information theory, and high-order thought theories. And on the right, you can see how the papers are distributed. Um, Most mention the theories, a lot support the theories, but very few challenge the theories. However, when we do science, what we mean to do is truly falsify our theories as opposed to bringing more empirical support. We should be trying to close doors as opposed to opening more doors. This is a very interesting situation, I think, for us to find ourselves in. And by the way, I don't think it applies just to consciousness science. I think this is a problem for science in general. In another bit of this research, what Liad did was to use machine learning methods in order to try to find which theory an empirical paper was actually supporting, even without knowing what the actual outcome of the theory was. And they found that, well, the algorithm was pretty good at doing that, which shows you that research tends to progress in silos, everybody with his own theory bringing support to it. But what we need is crosstalk. And crosstalk is exactly what the Templeton World Charity Foundation is doing now by supporting and in fact steering an initiative meant to accelerate research on consciousness. And that involves what they call adversarial collaborations. So the idea is that you get theory leaders to sit down and actually think of an experiment that would falsify one of the positions in presence. This is not something that we would do. I could go to Anil and tell him, hey, I have a great idea about how to falsify your theory, and he would get back to me and say, oh, that's great, let's talk about it next year, and then it would never get done. So this initiative is great in fostering these sorts of interactions between people who hold opposing points of view about the mechanisms of consciousness. And there's a few of these initiatives going on right now. Liad is involved in one, and I'm heading one at the very early stage with Steve Fleming. Here is an example from an ongoing adversarial collaboration where we compare a global neuronal workspace theory with the information integration theory. And as you can see, I won't go into the details, but the two theories make very different predictions, both about which brain networks are involved in subtending conscious experience, but also about the temporal dynamics of what goes on when a stimulus is processed consciously. So I think this is a terrific initiative that indeed we all hope will accelerate research on consciousness, and perhaps it is a model for science in general. Just a few words of conclusions now. I think we're left with this huge question. What is consciousness good for? What does it do? Why do we feel anything at all? Well, what would be the point of doing anything at all if the doing wasn't doing something to you? I think a central feature of conscious beings is that they care about their experiences in a way that zombies or AI systems do not. Everything that we do, the choices we make, depend on our subjective experience. That explains why we're quite willing to engage in very dangerous activities such as base jumping and other extreme sports, for instance. We're looking to experience the thrill of doing that. We seek pleasurable experiences and try to avoid bad experiences. So in that sense, subjective experience is absolutely fundamental to who we are. It has value, it has intrinsic value. We do things for the experience themselves. And so perhaps the function of consciousness is to make it possible for us to do that. Here's Dan Dennett again with this wonderful quote. How do we go from doing things for reasons to having reasons for doing things? I think that points at a critical juncture in evolution. Many organisms do the things they do because of reasons that are set up by natural selections. But we humans, and probably some other animals as well, do things for reasons of our own. And those reasons wouldn't be there were it not for consciousness. For without consciousness, there wouldn't be anyone there to have reasons about anything at all. So who is conscious? That's a big question. I think there's three features that are essential. First, I think we need massive information processing resources that are sufficiently powerful to simulate certain aspects of their own physical basis and inner workings. Second, I think that we need a continuously learning system that attempts to predict future states. I think that consciousness is something that the brain learns to do. And third, we need immersion in a sufficiently rich social environment from which models of yourself can be built. I think we become aware of ourselves in virtue of having to figure out what the unobservable mental states of other agents like us may be. But that's my own theory of consciousness, and I'll stop here before I let myself be tempted to fully explain it. So this is my final slide. Are we solving consciousness? Well, perhaps what we should instead try to do is to dissolve consciousness. And by this, I mean the hard problem of consciousness. Perhaps it'll just go away as we keep making progress, working on those easy problems that Chalmers was dismissing as more or less irrelevant. Nobody knows how that's going to go. 20 years ago, as I was thinking, man, perhaps one day one of us will land on the mechanism of consciousness. And now I'm not so sure. Perhaps it's a red herring to think that there is a single mechanism for consciousness. And perhaps there is such a mechanism after all, we just haven't found it yet. We'll have to see. And with that, let me thank you for your attention and conclude this presentation. Thank you.
Thank you, Axel. You don't hear the sounds of 3.4 thousand people applauding, but they would be if they could be. We're going to open the floor very soon, but we're going to give our three panelists a chance to ask a question and add some additional insight to the discussion. So what we're going to do is open up immediately with Liad Mudrik. Liad has 2 PhDs, one in cognitive neuroscience and one in philosophy, which is exactly the type of baggage that I think one needs in order to be able to make some progress in this field. Her lab at Tel Aviv University investigates high-level cognition, which includes researching the neural mechanisms underlying consciousness and its functions. She's also very much involved in this adversarial collaboration approach that Axel just talked about. It's an approach for validating theories on consciousness. So Liad, over to you to tell us a little bit more about this new methodology and anything that might have come to your mind during Axel's presentation.
Thank you. Thank you so much for inviting me. And also thank you, Axel, for this brilliant talk, showcasing how exciting the problem of consciousness is, and also gives us a lesson in modesty, reminding us that our consciousness might be very elusive, which is always super cool. And thank you also for referring to Itai Yaron's work, which is now under review and was conducted in collaboration with the wonderful Michael Pitts and Lucia Meloni. And one other key finding that we found there was that less than a third of studies in the field actually set out to test predictions by the theories. And only 7% tested more than one theory, which is, I think, also why this type of adversarial collaboration, which is theory-driven, is so important in our field. And I wanted to say a little bit about our experience in that adversarial collaboration, again, done with many people, so I cannot name them all, but co-led by Lucia Meloni and Michael Pitts. And I think the interesting process that we go through there might also be important for other types of other disciplines or other types of theories. So what happened there was basically 2 amazing days where the proponents of then 3 theories, integrated information theory, global neuronal workspace, and higher order thought, sat together with scientists and philosophers and tried to think about ways which could test their theories. Now, importantly, these are people who didn't really conversate with one another. So they met at conferences, but they never sat together and tried to challenge each other and kind of come up with experiments that would actually put their theories to the best test we could think of. I'm sure there are better tests, but it's one test at least that could be interesting. And then it took us a long time. So it was about 2 years of refining the experiments and outlining all the different outcomes. So we had like these huge tables saying, we do this experiment is taking place in 6 different labs around the world, 2 labs for fMRI, 2 labs for MEG, EEG, and 2 labs for ECOG. So it's also a combination of different neuroimaging techniques. And we basically had these tables saying, if we find this in fMRI and that in MEG and that in ECOG for this and that prediction, what would that mean for global neuronal workspace or for integrated information theory? And we had all these combinations of outcomes trying to say, what would that mean for each and every theory? And that was, I should say, an initiative by David Potgater from the Templeton World Charity Foundation. And I think there is something that I don't know how this will end, right? So we still have about 3 more years. And I'm not deluding myself that at the end, one of the theories will say, well, you know what, I'm completely wrong. But we do hope that at least there will be some refinement of the theories, of the predictions. Maybe there will be a big blow conclusion, but I want to kind of reduce the expectations because that would be, I think, a very surprising outcome. But just even the opportunity to kind of set the predictions in advance and being very open about it. So everything is open access. If at the end of the day, one of the proponents would say, well, you know what, that was not a good test. And then we can show him that we had a clear kind of written declaration saying that at the time you thought that this was a good test for your theory. So I think that this open science, all the data will be open to the community so people could curate it. So this kind of open science, early pre-registration, adversarial collaboration, working through dialogue, team science, has the potential to bring us one step closer, not to solving the hard problem, that's pretty ambitious, but maybe one step closer to understanding the problem better. But I want to ask you, Axel, one type of criticism that has been raised against our project and maybe also yours is that maybe the theories in the field are just not mature enough to be tested in such a way. Maybe we are not there yet. And I was wondering, what is your take on this line of criticism?
Well, that's only the case that many theories in consciousness science are sort of not sufficiently precise to be fully amenable to a thoroughly empirical, fully science-driven approach. But I think it's great progress anyway, because I think of theories as tools for thinking, really, and the same goes for computational modeling. So the more precise they can be made, of course, the more progress is to be expected. But I think the tools for thinking mostly, they're not set in stone, they're susceptible to being modified. And I think it's in this continuous interaction between empirical findings and theory development that we make progress in science. So yeah, perhaps it's a bit early, but in fact, my intuition is it's about the right time. I think we will find some answers with this approach. And you were right to point out that it's all open too, which is extremely important in the sense that a lot of the effects that I described, and in particular, for instance, subliminal perception, depends on empirical details. And so there might be tiny differences between the way different labs are doing things. And so just by sharing the methods and the procedures, we're already making progress and eliminating some possibilities and solving some methodological problems.
Thanks, Liad, for the question and for kicking off the panel discussion. So we're going to go right to Anil Seth. Anil, thanks for joining us today. Anil is professor of cognitive and computational neuroscience and co-director of the Sackler Center for Consciousness Science at the University of Sussex. In addition to his research on the biological basis of consciousness, he's also a well-known science communicator, and his latest book, which is entitled Being You, A New Science of Consciousness, will be coming out this September, in which he proposes some new insights into human consciousness. So, Anil, over to you.
Thank you, Fred, and thank you, Axel. That's very kind. Thank you for plugging the book. Very kind indeed. Before I ask this question, I just wanted to add one thought to this discussion that Liad started about adversarial collaborations. I think it's absolutely the right time. I think it's quite fascinating. I've been involved with another one, and the discussions have been very interesting and sometimes frustrating, because you find actually that these theories are incommensurate in many ways. They're not even theories of the same thing sometimes. So trying to pin down how to disambiguate them becomes rather difficult. You know, I think in this case, the one I'm involved with, one is very difficult to test at all, and the other isn't really a theory of consciousness. So, you know, how do you do that? Go figure. And, you know, I'll let you into a secret here, which is I think it's going to fail, but I think it's going to fail in an interesting way. And actually, that's what science is largely about. It's largely about trying to find ways to keep on failing in interesting ways. Now, Axel, that was a brilliant synopsis of the science of consciousness. I can quite understand why you are president of the Association for the Scientific Study of Consciousness. You've been a guiding light for us for decades now. And I very much like the way you finished the talk, moving from the idea of solving the problem of consciousness to dissolving.
I think I stole that from you. Anil.
I think you did, which is why I like it. And in fact, I was going to say this echoes, unsurprisingly, echoes my own take on how best to approach the science of consciousness, that you don't address the hard problem, but what I like to call, with a bit of tongue-in-cheek, the real problem of consciousness, how to explain, predict, and control properties of conscious experiences in terms of things happening, mechanisms in brains and bodies, accounting for properties of consciousness in terms of underlying mechanisms. I mean, this, after all, is what we usually ask from scientific explanations, not to explain why the phenomenon is part of the universe in the first place, but explain, predict, and control its properties. This seems to me a more pragmatic strategy for the science of consciousness, and one with some historical precedent. It's not long ago, after all, that life was considered by scientists at the time to be beyond the reach of mechanistic explanation. But the hard problem of life wasn't solved by finally locating an élan vital, a spark of life. It was dissolved by explaining, predicting, and controlling observable properties of living systems. So I want to move to the question, and the question is about the extent of consciousness in the world, and specifically about the possibility of synthetic, artificial, or machine consciousness. Now, many people think that consciousness might just come along for the ride once artificial intelligence or AI reaches some threshold, which is often assumed to be equivalent to human or general AI, something like that. But as you rightly pointed out, intelligence and consciousness are not the same thing, and our tendency to associate the two might reflect some kind of persistent and pernicious anthropocentrism rather than a deep insight into the necessary and sufficient conditions for consciousness. So you propose 3 criteria for who is conscious: massive information processing resources, a continuous learning system that attempts to predict future states, and as you say, consciousness is something we learn to do, and immersion into a sufficiently rich social environment from which predictive models can be built. But it seems that all of these conditions could be satisfied by current or near future artificial systems, stuff made out of similar things to my laptop or my phone. And the theories that you mentioned, global workspace and higher order theory, also seem to be implementable in this way. So the question is, do you think that such an artificial system would actually be conscious, or would it merely behave in ways that we, as outside observers, could no longer tell the difference? And if the answer is no, if something is missing, what is that missing thing? Could it be, as I might argue, that there is the living flesh and blood beast machine materiality of humans and other animals is significant in shaping and generating our conscious experiences?
Thank you, Anil. Tough questions as usual. I personally do not see any argument against the idea that AI systems could become conscious. But perhaps those systems would have to go through the same developmental trajectory that we go through. They would have to have an existence. They would have to want to be alive, so to speak, or at least powered on. And that is where there is a connection with living systems. It's exactly, I think, what Dennett's quote was reflecting. How do we go from systems that do things for reasons to systems that have reasons for doing things? And at this point, I think the main issue with most AI systems is that they're not motivated to do anything on their own, right? They just sit there, you can plug them off, etc. And so that is definitely a huge difference with our living systems. Now, I don't know what it, and it connects us directly with issues that have to do with life and death, and so with living systems. I'm not so sure, in fact, we want to go towards conscious artificial systems because they're immortal, they can duplicate themselves at infinity. So I think we'd be in pretty bad shape if we manage to actually get there. But how that's going to happen, I have no idea. But in principle, I see no fundamental objection to the idea that an AI system that is built or that grew in the correct way would be able to have some sense of its own existence and would be able to care for its own mental states, to seek pleasure, to avoid bad states, and so on and so forth. So perhaps a great question for AI research is, how do you convincingly make a robot capable of experiencing orgasm? I think that would be a terrific research topic. Maybe there's AI researchers working on that right now. But artificial pleasure, does that even make sense? Artificial pain, you can sort of imagine, or at least the behaviors that would lead you to avoid pain. But can an AI system actually experience pleasure, and what would it be? We don't know, but I think it's possible.
Thanks so much, Axel, and thanks, Anil, for the contribution from the panel. Our final contributor is Dr. Steve Fleming, and thank you, Steve, again for participating today. Steve is a Wellcome Royal Society Sir Henry Dell Fellow at the University College in London, where his lab investigates metacognition, our ability to assess our thoughts and performance, and use this self-awareness to influence our own behavior. Steve's book, Know Thyself, raises the intriguing possibility that we can train, that we can work with our metacognition in order to better learn and to make better decisions. So, Steve, over to you for your perspective on metacognition and how that fits into what Axel has been talking about today.
Great, thanks so much, Fred. I'm not sure how I'm going to follow robot orgasms, but yeah, thanks so much for the invitation. And Axel, thanks for a wonderful talk, really inspiring on the broad scope of the science of consciousness. So in Axel's talk, he mentioned alternative theories of consciousness. One of them is higher order theory, and this is something that we're actively working on in my lab. And the way we approach working on higher order theory is to study the relationship between consciousness and what psychologists call better cognition. So that's the ability to think about our own mental states and to have some sort of self-awareness of our own minds at work. And we think from research over the past few decades that while animals share some of the same building blocks of better cognition as humans, it seems that fully fledged self-awareness is uniquely human and emerges relatively late in child development, around the age of 3. And we can measure this in the lab by asking people to self-monitor their performance on a variety of tasks. And we know that if you have damage to certain networks in the brain, particularly the prefrontal cortex, that you can actually see impairments in metacognition without changing performance on the actual task that you're monitoring. And the other research in this line has suggested that metacognition provides a solid basis for lots of aspects of human flourishing. So it helps us learn better, make better decisions, interact and collaborate with others. And one I thought very interesting part of Axel's talk was this focus on AI, what's missing in AI. And one thing that we think is missing in AI is metacognition, is the capacity to be aware of what you do and do not know. So AI, as Axel showed, has achieved phenomenal success in feats of human intellect, such as chess and Go and so on. But when these systems are faced with out of distribution data that they've never seen before, they're often overconfident. This is a well-known result from machine learning research. And that's obviously a problem for deploying autonomous robots like self-driving cars and so on. And it's interesting that in the human research, this kind of self-awareness seems to be intimately related to the ability to model other people's minds. So again, both seem to emerge around the same time in childhood. So there seems to be this deep symmetry, as Axel mentioned, between thinking about ourselves and thinking about other people. And this perspective also sheds some light, I think, on something that's come up in the chat during the past few minutes. What's the function of consciousness? And this is a conundrum that lots of us are thinking about. And one potential answer to this is that consciousness, or at least the self-aware aspect of consciousness, is fundamentally social and evolved to allow us to communicate our thoughts and feelings to each other. So my question for you, Axel, is what do you think this relationship is between consciousness and metacognition? Does consciousness always involve some kind of self-monitoring? And does that relationship shed any light on the function of consciousness?
Yeah, thank you, Steve. Yeah, all I can do is raise more questions to answer that question. The relationship between metacognition and consciousness, and by consciousness there, I guess one means perceptual awareness, simply the fact of being sensitive to the world outside. I think that's a super interesting question, and my intuition would be to say, in line with your thinking, I guess. In fact, you should be able to answer that question you just asked. But in line with your thinking, and because we're both sort of high-order theorists, I think that indeed perceptual awareness involves some degree of inner sensitivity to your own mental states. And there's very interesting questions that have to do with how explicit does that process of noticing and redescribing your own mental states has to be for the mechanism of redescription to play the functional role that it plays. And perhaps it is the case that, in fact, perceptual awareness involves a sort of implicit metacognition. That is certainly, it seems to me, what high-order thought theories would tend to say. And I think we also can experience this. Take insight, for instance. I think that's a great situation where all of a sudden you notice a distinction between two things. All of a sudden you have an insight, all of a sudden you see a solution. And perhaps what happens over the course of early development is that, but we have no data on this, is that children do have these insight moments, basically. They notice distinctions that they didn't notice before. They become aware of the fact that this is different from that, whereas before it looked to be exactly the same. And perhaps those processes of explicit metacognition then get sort of automatized and in fact subtend most of what we see. Now, for the function of consciousness, yeah, that's a conundrum indeed. Nobody has a really good answer to that. I've been thinking about that a lot recently. And yeah, there's a slogan I can put forward, which is the function of consciousness is subjective experience. So that raises the question of what the function of subjective experience itself is. And as I've argued, I think that subjective experience has intrinsic value for us, that it's important, and that maybe, yes, metacognition is involved in that. You have to, in order for metacognition to play the functions you want it to play, you have to have mental states, you have to have a phenomenal field. And so that wouldn't work if such a phenomenal field did not exist.
Thanks, Steve, for the insights and the questions. You know, I think we've actually been able to address an incredibly complicated phenomenon from a number of really interesting angles. Now we're going to open up the discussion. The first person I'm going to ask to turn on the microphone is Waisu Tree. Waisu, are you? I hope you're with us. Would you like to ask your question, please?
Hi, my name is Wei Chu. My question was, in terms of AI consciousness or artificial consciousness, it seems that there are many moral and ethical implications for emerging consciousness, because we're necessarily going to be developing them. You know, we're not jumping immediately to a full-fledged like human level. You know, we're going to start with consciousness at the level of, you know, lower organisms going up to, you know, higher organisms. And it seems that I'm just wondering what are some thoughts about, like, how are we going to govern how we treat these artificial systems?
Thank you for that incredibly tricky question. It seems obvious to me that our attitudes toward suffering have changed considerably over the past decade or so. Think of all the work involving animals and the ethical issues that the treatment that we impose on animals has produced. And so, yes, you're right to suggest that if AI systems ever become conscious, so you seem to be fairly optimistic about when we'll get there. I tend to be skeptical, even though I believe it's will be possible. But there will definitely rise ethical issues, of course. I remember Thomas Metzinger, the German philosopher of mind, speaking in Krakow at the meeting of the Association for the Scientific Study of Consciousness a few years ago, and pointing out how important it is that we address those ethical issues now, way before we're even getting close to the point where those issues might actually arise. And I think that this is indeed very important. And I know there's a community of philosophers thinking about these issues. Metzinger himself was involved in discussing these issues with representatives from the GAFA groups, basically Google, Apple, and all the companies that are somehow involved in AI research. I think if you believe AI consciousness is possible, then there will be ethical issues. There's no question about that. And so the point is to say we have to begin thinking about these issues now, as opposed to later when those systems come to be.
Okay.
And jump in very quickly and add something, just
Go
very
for it.
that important question, which is, a lot of people I think that it's just should be one of our goals to try and build a conscious machine as quickly as possible. I just think this is a really bad idea. We should not be trying to do something that would have unknown, potentially massive ethical consequences, with the additional danger that for an artificial system that could, for instance, suffer some kind of pain or suffering, we would not even know what the signatures of that were. Whereas at least with other animals, some of them, we can at least infer that something bad might be going on. And the issue about preemptive ethics is completely right on. And I've been involved, for instance, in a number of discussions about brain organoids, these emerging lab-grown so-called mini brains, though they're not really. Now here, the danger is, I think, even more prescient, because these things are made out of biological material. They're made out of neurons. So immediately you shelve one whole big unknown about whether we can build something conscious out of silicon. These things are built out of neurons. And so quite rightly, there are some committees already being set up, certainly in the US and the UK, to try and establish legal, ethical and regulatory frameworks for this research well in advance of anybody actually thinking that a little bunch of brain-like cells in a dish could experience anything.
Okay, thanks.
If I may add one sentence, is that this is also one reason why it's so important to establish a theory of consciousness that would allow us to measure and give an answer to, at least in some way, this question. Because we can rely on our intuitions, and we can rely on preconceptions about what consciousness is. But once the field kind of converges around an account that tells you this has to happen in order to have consciousness, then other people, I don't think this should be neuroscientists, but other people, philosophers, thinkers, historians, they could then think what would be the ethical consequences of such a theory.
Yeah, terrific. Okay, yeah, we're touching upon some very, very important points. We'll pass the word over to Sridhar. Sridhar Vaisavaran, Sridhar, are you with us?
Yeah, hi.
Okay,
good
terrific.
evening. Hi. My name is Sridhar. I'm a consultant old age psychiatrist. I work more with people with dementia, and I do a lot of work clinically with people with dementia. One of the things that I see as people develop dementia and as they progress through the course of their illness is that they lose their insight, obviously, and then over time they also lose a sense of themselves, their environment, and what's happening around them. And you can see that the spark that makes the person who they are slowly fading away. And I wonder if there has been any research on kind of fading away of consciousness, a slow fading away, not the sudden onset of coma or things like that, but in people with Alzheimer's disease or other similar dementias.
Yes, thank you for that question. I don't know the answer about the extent to which people have specifically looked at the time course of these degenerative diseases that result in disorders of consciousness. It certainly is a terrible condition. I think it's also particularly painful for the people around those patients who experience this progressive fading away of the person as how she was. Yeah, I don't know. Maybe Liad or Anil or Steve have an answer to that. But I think it is extremely important indeed to sort of look at, but these are difficult studies to do, to look at how this progresses sometimes over a decade, and what goes away first, and how we end in a situation where indeed the person is still alive, she is still there, but she doesn't know who she is anymore, and one cannot sense the person who one knew. Steve, you wanted to add something to that?
Yeah, I think it's a fascinating question. It's something that we are actually starting work on in my lab. So we have a project on looking at awareness in different stages of dementia, and this is something that has huge societal relevance because the families of patients are often, as your question pointed out, very interested in trying to understand what mental life do they still have, especially at the severe end of the dementia spectrum where maybe verbal abilities have been lost. And so we're actually running, as well as the scientific project, we're running a public engagement project where we're working with filmmakers to create a film about the lived experience of dementia with a focus on changes in self-awareness. And so we're running a series of focus groups. This is what I'm doing. A lot of my day job at the moment is running focus groups with patients and their carers. And what's fascinating is that they use spontaneously words about self-awareness, about insight, about this loss of awareness of the change that the carers can see, but the patients themselves might not be able to see. And that dissociation is both often heartbreaking, but also fascinating from the perspective of consciousness science.
I think this also points out, if I may add to that, how complex consciousness is. It's not a single thing. It has many gears and aspects. And we may think, well, there's a switch. It's all or none, basically. And in fact, it turns out there is a switch, but that's about the level of consciousness. But insofar as the contents of consciousness and your presence to the world, then it appears to be much more graded, and and you can chip away at it over long periods of time to result in these demented states where you don't recognize the person who is there because she has lost bits of her memory, bits of her self-awareness, bits of her motivation, and so on and so forth.
Okay, terrific. Yeah, no, I think again, we're going to touching upon a whole range of issues here. So just to let everybody know, we're going to take the time for two more questions. The next question is going to go to Eleni Heinen. Eleni, are you with us?
So I'm Eleni Heinen. I'm in Hamburg right now and at the University Klinikum of Eppendorf. And my question would be, how do we go about the whole question of being conscious without being biased, or rather whilst acknowledging that we are biased, because most of us would agree that we are conscious? How do we sort of balance that while trying to empirically evaluate something which we are experiencing ourselves? Well, at least most people would say that.
Liad, you want to answer that?
I think this is indeed a critical question about how to study consciousness. Typically, people say, well, how can you isolate conscious versus unconscious processing? How can you create something in the lab that would capture only consciousness and not anything else, and that would resemble our consciousness outside the lab? And indeed, in recent decades, there have been several highly elegant methods that allow us to keep the physical stimulus constant, but change the content of consciousness so that we could try to isolate only that and track the neural activity that is related to it. But of course, as later studies have argued and showed, it's very hard to isolate only consciousness. So we will always have the prerequisites of consciousness and the consciousness and the consequences of consciousness that kind of interfere with our experimental designs. But still, what is nice is that the field has managed to yield several ways where we could actually create a situation for the very same stimulus. Once you see it, once you don't. And another way to study consciousness, as Axel said before, is to take people in different levels of consciousness, dreaming, non-REM sleep, disorders of consciousness, and compare what happens there. So studying consciousness in the lab is a challenge. Defining consciousness even before you go to the lab is a challenge. But we have ways to solve this challenge, or at least meet it to some extent, and be able to study some of the neural correlates and neural mechanisms that are involved with consciousness.
Thanks for picking up the microphone for Axel on that one. We're gonna go.
It's my honor to do so.
So we're gonna go now. We're gonna have one last question. Krutika Bhavishi. Krutika, are you still with us?
So my question was about plant consciousness. Do you feel that plants have consciousness, and based on the three, so you talked about three conditions that define consciousness. Do you feel that this is perhaps too limited, or to encompass plants into that?
Well, thank you. I mean, yeah, those statements are firing back at me now, but you know, look, I mean, plants are just absolutely fascinating. And there's a lot about plants that we do not understand. It even looks, I read that they may have something akin to a nervous system, except structured differently. We know they're social to some degree. There's wonderful studies about the complex ecosystems in forests that show how different plants interact, how they can exhibit both competitive and cooperative behavior, and in interaction with other organisms as well. I've always been fascinated by movies showing plants growing, particularly plants that cling to walls. If you speed them up, you really have a completely different feeling about the plant, because now that the speed of the movements is more familiar, they're truly exploring the world. The tendrils look almost like worms in the way they move, and so on and so forth. So I think there's a lot to wonder about plants. Now, given that we believe that consciousness involves necessarily some sort of nervous system, and that plants do not have any nervous system, I think I would be hard-pressed personally to grant them awareness, or even the possibility of awareness. But biologists come up with more interesting phenomena about plants all the time. They were shown to be able to learn, for instance, which is also a striking phenomenon. And so I think we're really at the boundary there between what we can find out about them. But I think that there's a lot of research that still needs to take place for us to fully understand how plants work. In a way, they're sort of alien to us. In a way, we live with them, and we share the world with them, but they're very, very different from animals.
Sorry, I just had another follow-up question. Could you think of an experiment, or could you think of any ideas which can help us to establish plant consciousness?
I never thought about it beyond reading interesting material about it, but there's this great Italian researcher whose name escapes me now, she has a book about plant awareness or plant life. She's a wonderful researcher. You should write her. I think she's very open to novel ideas, and she was responsible for this study showing how plants can learn, basically. It's a great domain. It's a bit out there, but I think that's exactly what fundamental research is about, is exploring the limits of what we know, and this is certainly an interesting direction to go towards.
Thanks for the question. Thanks for the reply. And we're going to try to sneak in one last question from Peter Orell. Peter, are you with us?
Thank you very much for the fascinating talk and discussion. So I'm Peter Orell. I'm a biologist based in Scotland. You mentioned that one theory is that consciousness naturally emerges in some biological systems, such as humans. But I was wondering what your thoughts are on consciousness emerging in wider biological systems. Essentially, if collective consciousness can emerge from a group of organisms, I suppose honeybees are a good example, but I'm also wondering from a wider perspective, I guess right down to simple microbes, to collective consciousness of more complex organisms such as humans.
Well, that is a tricky question, and people have expressed different views about it. There's a sense in which those are still separate organisms. And so even though there's a sense in which there is something like collective consciousness, you can sort of talk about what a society is aware of, so to speak, but then you put square quotes around it, because consciousness, as far as we know, is a feature that belongs to individuals. And so there's a lot we share with others, but our collectivities, be they artificial, humans, or non-human, able of awareness, I think that's few people would agree with that. Then you would also have to grant awareness to Google and to the internet, or to the whole of Europe, and that doesn't really seem to make sense to me. There's no sense. What is lacking there is the unity. So it's not that this collectivity cannot act in a unified way, but the system that is doing the experiencing does not belong to a single body. And so I think that's a challenge for those sorts of ideas. But you could also argue, contra that the brain is just a collection of individual cells. So this is another of these super interesting but very difficult to answer questions.
Peter, thanks for the question. Thanks for the. I think this is a great way to end the discussions today. We start from a very sort of philosophical point of view, but we really pass through very important questions that touch upon human well-being, that touch upon human health, and all of this sort of driven by this desire to actually use the scientific method in its purest form to try to see which path to go down in terms of getting to outcomes for humanity that will make a difference. And so thanks everybody for participating today. It was a great discussion. It was a great talk. Thanks, Axel. Thanks Anil. Thank you, Liad. Thanks, Steve, and for participating as panelists. And thank you for everybody for participating. I hope you all enjoyed the session, and we look forward to seeing you all at the next ones. So I'll just say goodbye to everyone and take care. Stay safe.